Class. See, thank you. I got a yes right there. I'm good. Danny. Thank you. All right. So, do you need something to write with? You good? Okay. All right. So we are going to do more practice with 5.2, definite integral. So everything that I did on the last set of notes was focused on the calculator portion. Just all calculus. Put in Riemann sum, left side, right side, all that stuff. But now in these notes, I'm going to go over a couple more that are by hand and why we do this. So this is sigma notation. Okay, this symbol is sigma. That's the Greek letter sigma. Funny? Why? Did you hear what she said? You're laughing though, so it's even worse. So you understood what she said. Well, I don't. So sigma notation. So we have the sum of the parts starting with k at 1. Okay, there we go right there. And going for n in that many terms that I'm going to have. So that means it's going to be n terms all the way out to here. That's how far we're going to go out, where k is going to be my first one starting there and going for my function of a, whatever I'm going to get there. So it's basically you're adding up the sum of all the parts. So when we were doing the Riemann sum, we were making rectangles, right? We were making rectangles, and a sum or summation is actually the addition of all those parts together. That's what we're going to get there. And so as we do this, though, the definite integral as a limit comes out to be, we're taking this to infinity. Okay, it's integral from a to b, the value of a definite integral from here to here. So we're going to have this value, delta x for k, and then as I'm taking the limit, and I keep going all the way over. So what it comes out to be is, there it is. Okay, so from A to B, it is partitioned at n subintervals equal length of delta x, that's my equal length, that's my b minus a divided by n. Then the definite integral of f over a to b is given by this because we're going to take infinite number of rectangles. So as we keep going closer and closer and closer, our smaller and smaller rectangles, we get closer and closer to an actual perfect value. So where the integral, so all the pieces that say, and we're no longer going to be approximating our answer using rectangles, where we're going to have an overestimation or an underestimation, we're going to have an exact answer. And that's what we're doing here with infinite number of rectangles. As I keep going this, delta x is the thickness of each one of those, where c to k is chosen by arbitrarily in the kth subinterval. So somewhere in there, we're going to have a function of that. So it just looks like this. So all that craziness for sigma notation comes out to just this. And I'm going to show you how to do that. So the integral from a to b, so lower, that's my start, upper, that's where I end, a to b of x. Oh, this is weird. Yeah, they messed up this one. This is actually going to be delta x, so a dx, so it's delta x, sometimes integral from a to b of f of x respect to x. So that is referred to as just delta x. That is the thickness of each one of my rectangles, where I take it to infinity. So I'm doing this in terms of dx. Eventually, in calculus 2, you're going to have a dx dy. So you're going to have both of them together. So you're going to integrate both parts at the same time. So, and this is kind of why I really like this one right here. So upper limit integration, integral sign, lower limit of integration, integral from a to b. When you find the value of the integral, you have evaluated the integral. Okay, x, where the variable of integration and the function of the integrand. This whole thing inside here is called the integrand. So when you hear that word, hey, that's the function we're talking about. So, example. So they took the sum, they took the limit as n goes infinity of the sum of the function, all that right there, where m to k was that value of x. That's what that basically turned into, of x. So mk is the x. As we rewrite it as an integral, it's no longer of my m of k. It is the integral of 3x squared minus 2x plus 5 dx. Now we are going to do that right there. So I'm going to take the integral from negative 2 to 4, 3x squared minus 2x plus 5. And that's going to be a dx. So if you're typing this in, especially for your answers, you want to put it like this, because that is implying that all of this is my integrand of my dx over here. Because it is possible to break it up into several parts, but we'll talk about that when we do the properties of this. Now, integral is the opposite of derivative. So I'm going to put a number up here, and I'm going to have you guys take the derivative of it. So I'm going to say 5x squared. All right, so I want you to take the derivative of this. Take the derivative of 5x squared. It gives me 10x. All right. So now working that backwards, that's what integrals do. That's what integrals do. So if I was to go from here this way now, what would I do? So if I'm going to go that, so 10x, integral of 10x. So to do that, what do you think I should do? I could divide it by 2, but where's the 2 in this problem? There's no square here, though. So I need to get from here back over to here somehow. Okay, so what do you think I should do first? You had a 2, but why did I have a 2 over here in my derivative? The derivative right here, I had a 2 in the exponent, right? Okay, and that 2 in the exponent, I multiplied it. Okay, you said divide by 2. That is correct. I'm going to take this and divide by 2. So it's going to be 10x divided by 2. But where did the 2 come from? The exponent. But now, how do I get the x squared? Very good. So this is going to be x to the first plus 1. So up here, I have to add 1 to the exponent first, right? So first I add 1 to the exponent, and then I divide by the exponent. Does that make sense? Okay, so if you notice, when we did the derivative, we multiplied first, and then I subtract 1 from my exponent, right? Okay, so we're going to do the integral of this problem right here. So what am I going to do first? What am I going to do first here? No. We're doing integrals here.
Oh, integral.
Add an exponent, so this is going to be x cubed, right? And then what do I do with that? I divide by 3 now, right? There we go. That's integration then. And we're going to do that for each one of these. So integration is the opposite of derivatives. So now this next one right here says minus 2x. Now what am I going to do? Plus 1 to the exponent, right? So this is going to be x squared over, okay, plus, very good, 5x, right? And that's going to be over 1. Does that make sense? Yes? So far.
It's like multiplying those x.
Okay. Now, because this is a definite integral here, we're going to actually evaluate the numbers for these. And that's going to go from -2 to 4. So I'm going to evaluate this now. 3 divided by 3 cancels. 2 divided by 2 cancels. I'm left with just 1, right? So right there. So this is going to be 4 to the third minus 4 squared, right? Yes? Okay. Plus 5 times 4. Now, this bottom part here, I'm going to subtract the bottom of my integral. So I'm going to do that again, but now this time I'm going to use the bottom of the integral by subtracting that. So that's going to be, let's see, it's going to be parentheses, -2 to the third minus -2 to the second plus 5 times -2. And I always like bracketing this because when you have a whole bunch of parentheses next to each other, you seem to kind of zone out and miss where each one is. And so where one starts, the other one begins. So all this right here is being subtracted. So I want you to add or combine or do all this math first before I can go through and subtract. So 3 to the fourth power. So 16 times 4. What is 16 times 4?
64.
Yes, it is. Okay. So 64 minus 4 squared is 16. And this is going to be plus 20. Minus sign all this. Let's do this over here. So 2 to the -2 to the third is going to give me -8. This is going to give me minus 4 and minus 10. All right, do the math. On the left-hand side over here, I'm going to get 68 minus the right-hand side, which is going to give me, what's that going to be, -22? I think so. -22. So it's minus -22, which is going to give me, that's supposed to be a bracket there. So minus negative gives me plus, so it's going to give me, what's that going to give me? At 90?
Yeah. U squared?
Yep, do you know why?
Why?
Area under curve. Just basic area.
So it's like, so that's like saying the area of a curve.
Okay, so let's see.
There's too many letters.
It's whatever my units are.
Yeah.
So all right, so I'm gonna go scratch pad here. See my graph. That was 3x squared, right? Yes. Minus 2x plus 5, right?
Yep.
So we can see it a little bit better here. And it's from -2. So I'm going to change my window. It was to 4, right? So let's take it to 5. There you go. So now I have my function here. So from -2 over here, wow, I should go up a lot higher because I can't see it as well. This should go up to there we go. That's better. So I'm going to take the area all the way under all this curve. So analyze graph. Ooh, let's do the integral. And lower bound is -2. Upper bound is going to be 4. So that's how we find the area under the curve. And that's what the integral is. Does that make sense? Is that nonsense? Is it possible sense? A little bit of sense?
Wonderland.
Okay. And by doing the calculator, what did I just teach you also?
I use a calculator.
Calculator can do it, right? Okay. So the calculator can do that. And so let's see if I go over here, menu, calculus, and let's do, yep.
Oh. Have you ever done problems that take you like 2 months to solve?
Uh-huh. It is -2x
Mine is 2x
plus 5. And it is going to be a dx, right?
5.
So knowing how to do it by hand is going to be beneficial for you. And knowing how to do it in the calculator is also going to be helpful, right? Since I allow you guys to use calculators on the test, I'm hoping a lot of these things become a lot easier. Now, let's go back to our notes. Okay, accumulator function. So interval over the closed interval, then the definite interval from a to x defines a new function from a to b, accumulator. So what we're going to do is we're going to take the derivative, the integral in terms of t. I thought I had one for this. The integral in terms of t and just evaluate. Just plug in your a and plug in your x. So it's the same thing we just did with those numbers, but this time you're just going to plug in a, you're going to plug in x. And then you're going to have the answer set up as a whatever the function is. So you're going to have a new function in terms of a and x. Okay, non-negative, and right here, area. And you know what? Let's save the rest of this for later, which comes out to this, and I also have another problem to go along with this. All right, so make sure you like, share, and subscribe. Hit that notification button. Support my channel.